5,600 years ago, the top of a mountain in Washington state turned to liquid and ran to the ocean. Not lava, not fire. Roughly 3.5 cubic kilometers of rock and clay peeled off the summit, dropped into a river valley, and began to move at 43 miles an hour in a wall 300 feet deep, burying whole forests as it went. It did not slow at the foothills. It did not stop at the lowlands. It traveled some 70 miles to the shore of Puget Sound, entered the water, and kept going, sliding another 12 miles along the seafloor, beneath what is now the port of Tacoma, beneath the Seattle suburb of Kent, before it finally came to rest. The mud is still down there, under the streets, holding the shape of the afternoon it arrived. The event has a name, the Osceola Mudflow, and the geology is not in dispute. 8 separate wood samples pulled from inside the deposit all carbon date to the same window. The flow buried 210 square miles of the Puget Sound lowland. Near the town of Auburn, it lies 260 feet thick, 2/3 of it below today's sea level. And the United States Geological Survey ranks the mountain that produced it among the most dangerous volcanoes on Earth. Not because of what it might erupt, because of what it is already built to do. This is Mount Rainier, and the thing that makes it lethal has almost nothing to do with fire. Today, 6 modern cities sit directly on the hardened body of that single afternoon. Tacoma, Auburn, Kent, Enumclaw, Sumner, Puyallup. Not one of them existed when the mudflow arrived. Every one of them now rests on top of it. The flat, fertile ground that made those valleys attractive to settle is not natural terrain. It is the leveled surface of a buried disaster, and the people living on it have, for the most part, no idea what they are standing on. The people who lived here before the cities did know. The Puyallup called the mountain Tahoma. Lushootseed speakers used the same name. Other regional nations carried their own. Different languages, different generations, and the same undercurrent of warning passed down about a mountain that was not to be trusted. The oral record was speaking long before the science arrived to confirm it. For most people, the mental model of a dangerous volcano is Mount St. Helens, a summit that swells, gas that leaks, a bulge that grows for weeks, and then a catastrophic sideways blast. Watch the summit, watch the deformation, watch the gas. That is how you survive a volcano. But Rainier does not kill the way St. Helens killed. St. Helens exploded sideways. Rainier slides. St. Helens threw ash across 3 states. Rainier moves wet concrete down river valleys. St. Helens needed an eruption to do its damage, and it announced that eruption for 2 full months beforehand. Rainier may need no eruption at all, and may announce nothing. That is the misdirection at the center of this story. Every instrument trained on the summit, every gas sensor, every tilt meter, every seismometer waiting for a swarm is watching for the wrong catastrophe. The real one does not begin at the top with fire. It begins inside the mountain with rot, and it can start on a clear day with no warning of any kind. The word for what Rainier produces is lahar, borrowed from Indonesian, and it describes what happens when volcanic rock, clay, and water are forced together and set loose by gravity. A lahar is not a flood, and it is not a landslide. It moves like flowing concrete, denser than a river, faster than a flood, and it carries boulders the size of cars, as if they were grains of sand. The numbers are difficult to hold in the mind. At full discharge, a major lahar can push 2.5 million cubic meters of material past a fixed point every second, on the order of 1,000 times the average flow of the Mississippi, compressed into a single pulse and loaded with rock. Its leading edge can stand 100 feet tall. If hot material was pulled in at the source, its interior can approach the boiling point of water, and when it finally stops and dries, it does not wash away like a flood. It sets like poor quality cement. Bridges caught inside it are crushed flat. Vehicles are folded. Buildings do not collapse. They simply cease to be there. This is the medium Rainier works in, and every ingredient it needs is already stacked on the mountain, waiting. Think of Rainier not as a peak, but as a machine with 3 components, stacked vertically, held in place by nothing but the angle of the slope. The first component is water, and Rainier holds more of it, frozen, than any peak in the contiguous United States. 26 named glaciers, roughly 36 square miles of ice, a total volume near 1 cubic mile, 5 to 6 times more ice than every other volcano in the Cascade Range combined. The Carbon Glacier alone is 700 feet thick at its center. You could stack a 60-story building inside it and still have ice to spare above the roof. This is not a mountain in the ordinary sense. It is a water storage facility built on top of a heat source. Stand on the summit, and the contradiction is physical. The air stays below freezing for most of the year. The rock is cold to the touch, even on a July afternoon. The wind makes a continuous low whistle that carries for miles, and in the silence between gusts, climbers report hearing the ice creak beneath their own feet. It feels like the most permanent place on Earth. It is one of the least. Directly beneath that frozen surface sits the reason. The second component is the rock of the cone itself. The third is clay. And it is the clay, not the ice, not the height, not the magma, that decides whether a collapse stops in the high valleys or runs 60 miles to the sea. Carolyn Dreger, a hydrologist who has spent decades at the USGS Cascades Volcano Observatory trying to make the public understand this mountain, has arrived at a conclusion that never changes, no matter how the data is turned. Rainier is configured to deliver a lahar whether or not it ever erupts. The fuel is already loaded. The water is in the glaciers. The rock is in the cone. And the clay, the decisive ingredient, is being manufactured inside the mountain on purpose and has been for hundreds of thousands of years. Here is the part of the story that does not fit on a postcard. The interior of Mount Rainier is being chemically dissolved from within, and it has been for as long as the mountain has existed. The agent is sulfuric acid, and the volcano makes it itself. Hot, sulfur-rich gases rise from the magma chamber through the cone and meet groundwater trapped in the upper edifice. The reaction produces acid. The acid attacks the volcanic rock, and what it leaves behind is not andesite or basalt, but smectite, a soft, swelling clay that absorbs water and loses what little strength it had the moment it gets wet. The process has a clinical name: hydrothermal alteration. In plain language, the mountain is rotting from the inside. You cannot see it from Seattle. On a clear morning, the summit looks carved from a single block of granite. It is nothing of the kind. Airborne surveys, helicopters trailing instruments that read altered rock by its weaker magnetism and lower electrical resistance, have mapped the decay, and the result is genuinely disturbing. On the upper western flank, in a bowl called Sunset Amphitheater, the clay-rich zone exceeds 500 meters in thickness. That is more than 1,600 feet of waterlogged mush near the summit, suspended directly above a river valley that drains straight into the western suburbs of Tacoma. 2 geologists, David John and Thomas Sisson, spent years climbing that flank, drilling it and running the samples, trying to map the rot. Their conclusion, now on file with the USGS, fit in a single word that ought to chill anyone downstream. The Upper West Flank, in its present state, is not a possible hazard, not a theoretical one. It is a continuing collapse hazard. The acid is still working. The clay is still forming. Every year, the mountain is a little weaker than the year before. This is the mechanism that turned an ordinary landslide into the Osceola Mudflow. Around 5,600 years ago, a steam-driven explosion, magma meeting groundwater, struck the summit. But the blast is not what destroyed the mountain. The blast merely nudged the rot loose. It triggered a slide that carried away 2,000 feet of the summit, and that slide was full of clay, and the clay held water, and the water made the mass flow. An ordinary rock slide stops within a couple of miles of its source. A clay-rich, water-saturated slide does not stop. It transforms in motion. Before the Osceola debris had traveled even 2 kilometers from the summit, it was no longer a landslide. It was already a lahar, and it had 70 miles left to run. What it left behind at the summit was a crater almost the exact size of the one St. Helens blew open in 1980, nearly 2 kilometers across. Over the following millennia, Rainier quietly refilled that scar with new lava, which is why today's summit cone is younger than the catastrophe that shaped it. But the Osceola collapse removed only the rotten eastern portion of the mountain. The western flank kept its decayed core, and that core is still up there, still hydrothermally active, still growing fumaroles and heated ground and fresh clay in exactly the zones that pose the greatest collapse hazard. The mountain reloaded. The trigger, when it comes, will not be the eruption. The eruption is only ever the excuse, and there is a case that proves the eruption may not be needed at all, a case far closer to the present than 5,000 years ago. Around 1507, while Michelangelo was 1 year from beginning the Sistine ceiling, and Henry VIII was 2 years from the throne of England, the western flank of Mount Rainier let go again. The event is called the Electron Mudflow, and it poured 60 kilometers down the Puyallup River Valley. Where it entered the lowland, it stood 100 feet deep. 20 miles downstream, it settled out at 26 feet, killing every living thing in its path. Douglas firs 10 feet across were ripped from the ground, carried for miles, and buried where they came to rest. They are still there. In the 1990s, a geologist named Patrick Pringle, driving through the town of Orting, noticed a construction site exposing those buried trees, cored the long-dead trunks, matched their outermost rings against the regional record, and pinned the death of the forest to the late summer of 1507. A town of about 4,400 people now sits directly on that deposit, Orting, Washington. Its streets are flat because they rest on 20 feet of hardened lahar. The soil is fertile because it is volcanic. The location is convenient because the valley is wide and the river runs calm. Everything that makes Orting a pleasant place to live is a direct product of the disaster buried under it. The first geologist to describe the Electron Mudflow was Dwight Crandall of the USGS, who published a detailed account of the deposit in 1963, but could not pin down its trigger. His radiocarbon date came back as 530 years before present. Give or take 2 centuries. Useful, but far too coarse to name the event. It took Patrick Pringle's buried trees 3 decades later to sharpen a 200-year smear into a single summer. And here is the detail that has unsettled the science ever since. The Electron Mudflow cannot be matched to any eruption. There is no ash layer beneath it, no volcanic deposit correlated in time, no sign of magmatic disturbance anywhere in 1507. For decades, that was filed as a gap in the record. Surely the evidence had simply eroded because the alternative was too uncomfortable to state. The alternative is now the USGS working hypothesis. The largest lahar at Mount Rainier in 2,500 years may have been triggered with no eruption at all, set off by a small steam blast that left no trace, a release of hydrothermal pressure, or simply an earthquake. In the unusually blunt phrasing of USGS geologist William Scott, the Electron Mudflow sort of keeps us honest. It is the proof that this mountain can kill on a clear day, for no reason anyone would see coming. There is one trigger in particular that removes the last comfort. Rainier sits in the foothills of the Cascadia subduction zone, the fault that ruptured in 1700 at magnitude 9 and is now statistically overdue. A great Cascadia earthquake would shake hundreds of feet of rotten, waterlogged clay for 3 to 5 minutes. The epicenter would not have to be anywhere near the volcano. The shaking would only have to be strong enough. A mountain already described as a continuing collapse hazard does not need its own eruption to fail. It needs a hard enough push from a fault 50 miles away. And that fault is loaded. The clay-rich lahars, the Rainier kind, do not correlate with volcanic activity. They can arrive with no volcanic warning whatsoever. Sit with what that removes. The entire modern apparatus of volcano monitoring, the gas spectrometers, the tilt meters, the seismometers listening for the tremor of rising magma, is designed to catch a mountain waking up. It assumes the danger announces itself from below, slowly, in the language of magma. Rainier's worst-case flow may speak none of that language. It can be set off by a fault that has nothing to do with the volcano's plumbing, or by the simple, silent fact of clay that has finally weakened past the point the slope can hold. There may be no crescendo, no buildup, no window in which an expert says this is beginning. There may only be a normal morning, and then a wall of mud in a valley where a moment before there had been a river. Understand what that means for the people downstream. Mount St. Helens warned its observers for 2 months. Earthquakes, a visible bulge, steam, gas. The system gave time. Rainier may give none. A volcanic catastrophe with no volcanic precursor, no earthquake swarm, no deformation on satellite, no plume of gas. The first sign that something has gone wrong on Mount Rainier may be the lahar itself, already moving. That is precisely why the warning system that exists is the kind it is. The Mount Rainier lahar warning system, built in 1998, does not predict. It detects. Acoustic flow monitors line the upper river valleys, listening for the ground vibration of a lahar already in motion. When they feel it, they trip automated alerts, and sirens follow within minutes. The system works, but read what it quietly concedes. It can only warn after the lahar has started. It is not an early warning system. It is a stopwatch that starts when the disaster is already coming down the valley. Nearly 5 centuries passed between the Electron Mudflow and the day anyone built an instrument to catch the next one. The mountain did not wait for us to be ready. Civilization simply got lucky. And the next time it moves, the alarm will not come from the summit. It will come from a flow sensor bolted to a bridge in a forest. And from the instant that sensor trips, the clock in the valley is already running. Richard Iverson, a debris flow specialist at the Cascades Volcano Observatory, spent his career studying how a mountain becomes a fluid. He and his team built a simulation of the west flank letting go and fed it everything they knew. The geometry of the slope, the volume of ice, the clay in the upper edifice, the shape of every valley downstream, the position of every town. Then they ran it, and it returned a set of arrival times. Inside Mount Rainier National Park, the lahar reaches inhabited ground in about 5 minutes. Outside the park boundary, 15 minutes to an hour, depending on the valley. 5 minutes is not an evacuation window. It is barely a recognition window, barely time to understand what the siren means before the wall arrives, and it assumes you are awake, on foot, already facing the right direction, with a clear route to high ground. It does not account for a bridge that has dropped, a road already jammed, a school in session, or a night in winter. This is why the town of Orting drills for it, residents practicing the walk to high ground, a route of roughly 2 miles, at a pace that is not a stroll. On the first Monday of every month, the sirens sound a test tone across the river plain, a low, sustained note followed by an instruction in 2 languages, and then the silence resumes, and the river keeps moving. The drill ends. The mountain does not, and the exposed population is large. At least 80,000 people live inside the official lahar hazard zones, Pierce County's broader estimate for a full Osceola scale event places some 2.5 million people and around $40 billion of property inside the potential footprint. Everything about the system is now known. The ice measured, the clay mapped, the collapse modeled, the arrival times calculated, the sirens installed, the drills practiced, the hazard maps published. Only one variable remains open: the timing. And there is one detail that does not appear on any hazard map. The 2 counties in the lahar's path made opposite decisions. Pierce County, which contains Orting and Puyallup, restricted construction in the inundation zones, installed the sirens, ran the drills. King County, more populous, home to Seattle, and squarely in the path of a large Osceola-scale lahar that the USGS has documented reaching the suburb of Kent, has no zoning restriction for volcanic hazard at all. None. The historic flow is under those neighborhoods. The path is open. The deposit is beneath the city, and building continues on top of it as though the ground were ordinary. 2 counties, 1 flow path, 2 different answers to the same geology. The mountain is entirely unaware of the line drawn between them. When it moves, it will not consult the county boundary, and the people on the wrong side of that political decision will have received no restriction, no warning siren network as dense, and, in many cases, no idea that the flat, convenient ground beneath their homes was delivered there by the last catastrophe. There is one force acting on this mountain now that was absent in every previous cycle: climate. Rainier has lost roughly 40% of its glacier area over the last 120 years, according to the National Park Service. This is not a footnote, it is a mechanism. As the glaciers retreat, they uncover more of the hydrothermally altered rock, the soft, clay-rich material on the upper flanks, and expose it to the open air. Freeze-thaw cycles pry at it. Rain saturates it. Shifting snow load works it back and forth. The rock does not strengthen with exposure, it weakens. A mountain shedding its ice is also shedding its restraint. In 2025, the glaciologist Maury Pelto reported that Rainier now appears visibly darker from Seattle and Tacoma. Gray rock showing through where white ice and snow used to cover the mid-mountain slopes. That change is not cosmetic. Exposed rock absorbs sunlight. Absorbed heat accelerates melt. The melt exposes more rock. The system has a feedback loop, and the loop runs in the direction of collapse. Now set that against the clock. Major lahars at Rainier recur on the deposit record of the last 10,000 years, roughly every 500 to 1,000 years. And the record is not sparse. The Osceola was 5,600 years ago. The Round Pass Mudflow followed around 2,600 years ago. The national lahar ran down the Nisqually Valley somewhere between 2,200 and 500 years ago. The Electron was 1507. These are not rumors. They are dated layers stacked in the river valleys, one catastrophe on top of another. The whole history of the mountain written in mud. The interval since the last great lahar is now 519 years. The mountain has already crossed into the lower bound of its own recurrence window, and it is entering that window not in its old, ice-armored condition, but weaker, darker, and losing its restraint faster than any previous cycle. The arithmetic does not predict a date. It does not need to. It only needs to move the odds in one direction, and it is. There is something almost philosophical buried in all of this. Every civilization assumes the landscape it inherits is the landscape it has. But the valley where Orting sits only looks like a valley. In the geological sense, it is a delivery channel. The plain where Tacoma's port operates is not a plain. It is the leveled top of an ancient flow. The flat fields outside Auburn and Kent are not fields. They are the smoothed surface of a buried catastrophe, waiting to be resurfaced. The mountain is visible from every part of the Seattle-Tacoma metropolitan area on a clear day. 3.5 million people look up at it whenever the clouds break. Most of them know it is a volcano. Many of them do not know what kind. Do not know that its danger has nothing to do with the lava they are watching for. That it has done this before. That it has done it without warning. And that it has done it without a single drop of lava. The 5-minute window is usually described as the time it takes a lahar to reach the first town. There is another way to describe it. It is the amount of time between when the future arrives and when the past finishes. Mount Rainier has crossed the threshold where its next great flow is no longer statistically distant, but statistically expected. The question is not whether the mountain will move again. The mechanism is loaded, the restraint is failing, the clock is inside the window. The only question left is whether the morning it chooses to move lines up with the one moment anyone happens to be paying attention.